In this question, an object of mass 2m is attached to a spring of spring constant k. It is at its natural length initially. Then these masses are attached and it is given that this is having acceleration a1, this is having a2, this is having a3, somewhere in between at any condition. These are the notations for its accelerations. And it is said that the maximum extension in the spring when this is going to move towards right is x0. So naturally it is going to move to and fro. Now what we have to find is the correct options from these given options. So at the first place, that if I see that this 2m is moving with the acceleration a1, so naturally this pulley will be going down with the acceleration a1. Now if it is going down with the acceleration a1, this part is going down with acceleration a1, this part is going down with the acceleration a1. So applying a constraint on this string, it will be going away, so it is plus a2 going towards, so minus a1. With that notation, I'll have minus a1 plus a2 minus a1 plus a3 equal to 0. So if I solve it further, I'll get a1 equal to a2 plus a3 by 2. Now, if you see this fourth option, that is a2 minus a1 is a1 minus a3, it turns out to be the correct answer options. Now, if you see the options, you are having at x equal to x0 by 4, at x equal to x0 by 2, x0 equal to, means now your objective is to first find the x0, that is the maximum extension in the spring. So what we'll first of all do, I'll try to write the equations of the motion for all the three masses. So what will be those? Here it is having 2t, here it is having kx, say in between the long extension is x, then 2t minus kx equal to twice m a1, this will be the first equation. Then for this m, it is mg minus t equal to ma2. For this twice m, this is 2mg minus t equal to twice ma3. Now I have these four equations, this and these three equations. Now what I want is I just want to write a1 in terms of x, so I'll have to eliminate t. Now for that, first of all, what I'll do here, mg minus t equal to ma2, so I'll multiply this equation by 2. Then what I'm going to get, twice mg minus 2t equal to twice ma2. Now I'll add this twice mg minus t equal to twice ma3 with twice mg minus 2t equal to twice ma2. So after addition, I'm going to get this equation. Here I'll get a2 plus a3 and I'll substitute this a2 plus a3 with this twice a1. And then after solving it, I'll get the value of tension to be 4mg minus 4ma1 upon 3. I'll substitute this value of tension in this equation. And then if I substitute it in this equation, I'll get 2 into this tension value minus kx equal to twice ma1. If I further simplify it, I'll get a1 equal to 4g by 7 minus 3kx upon 14m. Now, how I will use this condition of a1 for finding all these things? So, well, a1 can be written as dv by dt, and it can also be written as dv by dx into dx by dt. So, it will be v dv by dx, and therefore, it will be v dv by dx equal to 4g by 7 minus 3kx by 14m. If I integrate it, now whenever it will be having a maximum elongation, its velocity is going to become 0. So I'm just integrating it from 0 to 0. Now due to that, what will happen? That this is 4g by 7 0 to x0 dx minus 3kx by 14m 0 to x0 dx. So all this integration, and I'll get x0 equal to 16mg by 3k, whereas they have given it as 4mg by k. So definitely this is a wrong answer. Now further, I'll write the equation of a1 because they have asked me the a1 at x equal to x0 by 4. Now I'll just substitute in this equation of a1 x equal to x0 by 4 and value of x0 from here, and I'll get a1 will be equal to 2g by 7, and here again it is given as 3g by 10, so definitely this is a wrong answer. Then you want to find the velocity at x equal to x0 by 2. Now how you'll get that velocity? So you use this same integration, but now it will be going from 0 to v, and this will be going from 0 to x0 by 2. So you just have to write this integration, do the integration, put the value of x0 which is 16mg by 3k, and after solving this you'll get v equal to root over of 32 mg square upon 21k. Whereas it turns out to be 9 mg square upon 5k, which is again a wrong answer. So the only correct option for this question was option D. Now we will try to solve the same question by the simple harmonic motion concept. Now here when we have solved, we got the A1 as 4g by 7 minus 3kx by 14m. Now if I take out that minus 3k by 14m, then I'll get x minus 8mg by 3k. So now this is going to be again a SHM in which your omega square is going to be 3k by 14m, and it will be having its mean position at x equal to 8 mg by 3k. Now what we will do is we will try to go for these results by some different method. Now first of all, I need to understand one simple concept. If suppose you are having a pulley and this is of mass m1 and this is of mass m2, and let's say it is moving up with the acceleration a, then the tension developed in this is going to be how much? Here it will be, let's say t, then this is 2t, and this t from the standard formula, it turns out to be twice m1 m2 upon m1 plus m2 into g plus a. Now why g plus a? Because it is moving up. If it would have moved down, g minus a. If it is having no acceleration, only g. Now I want to replace this two mass system by a single mass system having the same tension 2t with m dash. Now what should be that condition? That twice t should be m dash into g plus a. It means twice t is nothing but 4m1 m2 upon m1 plus m2 into g plus a should be equal to m dash into g plus a, and hence our m dash turns out to be 4m1 m2 upon m1 plus m2. Now this is the effective mass I should substitute for this complete system. Now if I use this for it, then my new figure will be having a spring constant k here, this 2m associated with it is here, and then finally you are having this mass m dash which turns out to be, now how much will be that? So it will be 4 into m into 2m upon m plus 2m. So it is nothing but 8m by 3. So this is 8m by 3. Now it is going to perform the SHM. So I will have to find its omega. Now how much will be omega? Omega is nothing but k by m. Now how much it is having the m? Twice m plus 8m by 3, which turns out to be 3k by 14m. Now we are getting the same result which we got for the earlier calculation. Now what I want is the maximum elongation in the spring. Now when it will have the maximum elongation? When it goes to some displacement of x and it stops. It means the loss in potential energy should be totally getting converted into spring potential energy, and therefore 8m by 3 g x naught should be equal to half k x naught square. So how much is the x naught? It turns out to be 16 mg by 3k. This is the maximum elongation that spring will have. But here it is having the maximum elongation. It means it is starting from x equal to 0 and going for x equal to 16 mg by 3k and again coming to rest, means it is performing the SHM between these two extreme points. So naturally, what should be the mean position? The mean position should be half of this. This is the x equal to x naught by 2, which will be 8 mg by 3k. So it should be a mean position for it, and even the amplitude will be same, because from 0 to x naught it is going coming back. So mean position is at x naught by 2. From there it is going up to x naught by 2. So mean position is x naught by 2 and amplitude is also x naught by 2. So here also it is getting matched with it. Now they were asking us to find the velocity when it is having x equal to x naught by 2. Now considering it to be SHM, we know that v is equal to a omega. Now how much is the amplitude? As I said, amplitude is x naught by 2 and omega. So you straight away got, you have x naught, you have omega, so you can get the velocity v. Similarly, they have asked you to find the acceleration at x naught by 4. So what is the acceleration? Acceleration is omega square x. So that is you'll just have to substitute at x naught by 4, means this omega square x naught by 4. So you just substitute this value of omega square x naught by 4 and you'll get the required result. Now this question was little bit lengthy and you have to think a lot. And unfortunate part for this question was the option which you get within a minute was the only answer option for this question.